Existence on a rogue super-Earth would be challenging, yet it has been shown that creatures can survive in even the most harsh environments on ordinary Earth. A new research suggests that a certain type of planets may be able to support life for tens of billions of years. Super-Earths are rocky planets that are larger than Earth, but smaller than ice giants like Neptune. They are common in star systems all around the Milky Way. In contrast, our solar system may be an exception in that it lacks one of these planets. The concept of planetary habitability should be reconsidered and expanded upon in light of the new evidence that suggests so-called cold super-Earths, which orbit their stars at a distance greater than twice that of Earth from the Sun, can maintain temperate surface conditions for up to 8 billion years. Because these rogue planets would not be impacted by the destruction of any host star, certain super-Earths that are expelled from their parent star systems by gravitational perturbations or other means may be able to sustain liquid water habitats for up to 84 billion years. Scientists believe that while examining such possibly suitable planets, we should have an open mind since habitable planets may vary greatly from Earth. When thinking about such strange ecosystems, it's crucial to exercise caution and avoid drawing hasty judgments since we know so little about them and most of it is still up in the air. Since it is difficult to detect these frigid super-Earths with modern telescopes, the new research is based on theoretical models of these fascinating planets rather than actual sightings. The majority of exoplanets are found where they pass in front of their star from Earth's viewpoint, which results in a tiny decrease in brightness. As a consequence, all known super-Earths have very brief orbits with periodic brightness dips, which makes it easier to locate them with telescopes. Super-Earths in farther orbits, however, have long been thought to be attractive candidates for the hunt for alien life. According to models, these planets might continue to exist for billions of years with their original atmospheres, which are dominated by hydrogen and helium gas. These atmospheres are different from those that surround some of the rocky planets in our solar system, such as Earth, which developed atmospheres with more complex compounds, such as oxygen, carbon dioxide, and nitrogen gases. Since then, further research has been done on the possibility that liquid water may exist on a planet with a primordial atmosphere. This theory has been around for more than 20 years. Scientists analyze how long liquid water might be present and what would be required for a planet to have the longest feasible period of liquid water in order to further examine the evolutionary component. Scientists emphasize liquid water in their hunt for extraterrestrial life because it is the essential component for life as we know it on Earth. According to the research, they performed over 1,000 simulations of planets with various masses, atmospheres, and orbital distances to investigate the possible exotic habitability of frigid super-Earths with primordial atmospheres. The scientists found that planets with atmospheres 100 to 1,000 times thicker than Earth's atmosphere and masses between 1 and 10 times that of Earth may be a more habitable region. Planets that are set at distances even beyond orbit of Mars may be able to retain this hydrogen-helium envelope. However, planets that orbit their stars too closely are likely to lose their primordial atmospheres due to the strong stellar glare. These atmospheres might operate as greenhouse gases at this theoretically safe distance by trapping infrared radiation, creating a source of heat that could support life in seas of liquid water. According to the research, these type of planets might support life for 5 to 8 billion years until finally becoming uninhabitable after their stars expanded during their terminal phases. In a surprising development, the researchers discovered that the models predict that rogue planets with atmospheres that are just 1% the mass of Earth and 10 times as huge as Earth may support life for an incredible 84 billion years. According to the findings, these unbound planets would likely be too hot for life right now in the universe's 13.8 billion year history, but they may become habitable over the course of the next few billion years. Any hypothetical aliens would have to deal with environments that are quite different from Earth, such as high surface pressures and a lack of direct sunlight due to the atmosphere's thickness. The team does point out that certain creatures depend on chemical energy sources rather than solar energy, and that extreme life forms on Earth may withstand high pressures in deep ocean depths. The study's implications are intriguing. More investigation and ideally first-hand observations are required to support these preliminary conclusions. 3 crucial issues need to be addressed in the future. The first is if our conclusions remain true as we make our model more realistic. We conducted a few trials to see how resistant our findings are to altering parameters. However, we still simplify things, which has to be fixed in further work. We don't really allow the water to interact with the atmosphere in our model, which may be crucial. The second is to investigate the likelihood that planets with the proper circumstances for liquid water may arise. The third is to consider what can be measured about such planets to ascertain whether or not they contain liquid water. To that effect, the scientists stressed that these unique exoplanets may be observable by next-generation observatories, such as NASA's upcoming Nancy Grace Roman Space Telescope or the newly launched James Webb Space Telescope. Although it is unlikely that super-Earth-sized planets with these beginning circumstances will exist, it is plausible enough that they will make up a significant portion of the habitable planets in the galaxy. We anticipate that in the near future, our knowledge of this exoplanetary population and its potential habitability will significantly advance. China announces a huge Earth 2.0 project, with a next-generation space observatory scheduled to launch by the end of 2026. China hopes to discover the first Earth 2.0, or planet like Earth around a star like the Sun. The so-called Earth 2.0, or ET mission, spearheaded by the Chinese Academy of Sciences, would be the first telescope built to determine the frequency of these Earth-like planets in our galaxy, the Milky Way, as well as the variety of orbits they inhabit around their host stars. The ET project will detect thousands of terrestrial exoplanets across a broad range of orbital periods and in interstellar space, and will look for elusive Earth twins circling solar-type stars. This major worldwide search for possibly habitable planets has a strong focus on Earth 2.0s. Other telescopes might locate these planets and search them for biosignatures, which are indicators of life, in order to learn more about one of humanity's most enduring questions. Are we alone in the universe? Beyond Earth-like planets, the project will answer several questions concerning a variety of different exoplanet types, such as free-floating planets, commonly referred to as unbound or rogue planets that have been expelled from their star systems or that originated in interstellar space. 7 telescopes are part of the observatory's basic design, and they will spend at least 4 years scanning the sky from a position of the second Lagrange point, a gravitational balance point between Earth and the Sun that is also the location of NASA's James Webb Space Telescope. The 7th telescope will be pointed towards the Milky Way's core and will look for microlensing events, which are signs of free-floating planets. When the gravitational fields of these dark worlds twist light from sources behind them, these signals appear, giving astronomers a rare look of rogue planets that are often hidden from view. Together, the microlensing and transit telescopes will fundamentally alter how we see terrestrial planets across a wide range of orbital and free space distances. Thank you for watching. Don't forget to like the video and subscribe to the channel. Until next time.